What's up everyone? So today I'll be talking about circle properties, and there are 8 properties over here listed in my handouts. I'll be talking about all of them because that's going to make the video really long, so I'm only going to be focusing mainly on angle at center is twice angle at circumference. That's because there are other situations which are classified under this property, but they look really similar to some other properties listed over here. Okay, so this set of handouts, you can go over to my website, which I'll be putting the link to my website in the description below, so you can head over and look for the section on learning materials. Go down further, you can find geometry and circle properties, and you can download. It's freely available for you to use. Alright, I will also be putting up the link to this Geogebra resources made by this person called Mr. John Trenter, which I don't know who he is, but I found his resources really useful and simple to use, so do head over there and look it up. Okay, you can actually use some of these free resources to understand geometry better. Okay, so we'll be going over to angle at center is twice angle at circumference. Okay, over here you see this structure, which usually are the ones that are used in many books, many textbooks. You actually see this quite being associated with this property. Okay, so some people like to call it the arrow structure, whatever it is. You probably find this quite recognizable. Okay, so the angle at circumference is the one in blue and angle at center is the one in red. Okay, so clearly angle at center is twice angle at circumference. So indeed, this angle over here is the angle belonging to this point, and between these two lines that is on the circumference. Okay, so that aside, all right, I'm going to now start to slide this point further down until some of the lines actually coincide with each other, and you notice that now you have this flag shape looking structure, which you can actually find on my handout below over here. Okay, so that's the first structure. You need to see that from the original structure, you actually just need to slide one of the point, you actually get to this structure. Alright, if I were to actually slide this further down, I actually get this structure that looks a little bit like what I would describe as a butterfly structure. Okay, so this is another situation where this property can be used. However, the problem with this is that this situation looks deceptively like angle in the same segment. Okay, so there are fundamental differences between these two properties clearly. Okay, this angle in the same segment, you notice that these two angles are the same, these two angles are the same, whereas in this situation, these two angles are clearly different. So how do I identify which situation I use which property? Okay, so for angle at center is twice angle at circumference. Notice that there are a total of 1, 2, 3 points on the circumference, and the 4th point is on the center of the circle. Whereas angle in the same segment has 1, 2, 3, 4 points on the circumference. So that's a fundamental difference between these two properties. So once you can actually categorize them accordingly, you should be able to apply them correctly. Okay, let's go back to angle at center property, and let me just slide this back to the original situation, and I'm going to slide these 2 points at the side to here. Alright, so let me just find one angle which is quite easy for us to understand. Unfortunately, that's a rounded off number, so therefore you might actually see some discrepancies, so it doesn't really matter. Okay, so now that we get to here, we notice also that this angle at center is indeed twice angle at the circumference. Now there are 2 things over here. Number 1, this looks also deceptively like another situation, which is that of the cyclic quad. Now, in the cyclic quad situation, the opposite angles sum up to 180 degrees, like this situation over here. Of course, if you were to slide them around, doesn't matter, okay, you will still be able to get something which sums up to 180 degrees. Okay, so that's for that. Now, here, there's a bit of difference. What we're looking out for is the angle at center is twice angle at circumference. Now, the fundamental difference is that the situation for here is that I have 3 points on the circumference, 1 point at the center. Whereas for the cyclic quad situation, I have a total of 1, 2, 3, 4 points on the circumference. So again, there is this difference that for cyclic quad, the 4 points are on the circumference. Okay, whereas for the property of angle at center is twice angle at circumference, you have 3 points on the circumference, 1 point at the center. So that's the first thing I want to talk about. The second thing is a lot of students also make this mistake. They think this angle inside here, all right, is the angle at center. So take note, it is actually the reflex angle outside that is the one that we are talking about when we are talking about the angle at center. What happens if this angle at center becomes an obtuse or an acute angle? What's going to happen is the original structure. All right, so back to here. Okay, so I want to talk a little bit about an extension of this situation. So let me just try to find the original one I was using. All right, and if one of the points starts to slide down until in between reflex angle and obtuse angle, which is the 180 degrees, so the angle at center now is 180 degrees. What we have is the angle at circumference becomes 90 degrees. Now this is the case in my handout, which I mentioned over here as the right angle in a semicircle. So this is an extension of the angle at center is twice angle at circumference. So I hope this video has helped you to see the various situations which can be classified under angle at center is twice angle at circumference, as well as what are the differences with some of the other properties in this topic, all right, as well as also the extension of right angle in a semicircle. So I hope to see you next time round as we explore more in mathematics. See you around.